Hey everybody, this is Larry. This is March 31st of the... It's the last day of the March Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. So this is the last of the month, but it also means it is the last of the year because I think the first daily poem starts on April 1st, which seems like a joke, but... But that aside, so that means that we've actually been doing 4 full years of streaks after this poem. So yeah, I'll probably do a community post on YouTube or whatever, and kind of check that out. Ooh, I'm gonna plug in my power. Plug that in before I forget. But yeah, so definitely an exciting time. 4 years is a long time. Every day. Sometimes I forget to submit, but I have 4 years of videos just on these daily poems. Many of them repeats because, well, don't blame that on me, blame it on Leetcode. But yeah, so I just wanted to kind of point that out. And then the other thing I want to point it out is, the Leetcode contest, the bi-weekly contest was earlier today. I did pretty okay. I actually ended up finishing 44th, but there were a lot of server issues. I think there is a debate about making it ranked or not, or unranked. The people who are in favor of it, and also if you just want to see me solve this problem, maybe skip ahead a little bit. I'm having fun, kind of doing the drama a little bit. For those of you who are unfamiliar with the Leetcode contest, basically they happen twice. Well, they happen every week on. I want to say Saturdays because it's Saturdays here, but you have to make sure that is the correct time. But basically, the 2 contests, one is weekly, which it happens for me anyway, 10:30 p.m. on Saturday, and then the bi-weekly, which is every 2 weeks, 10:30 a.m. on, well, also Saturday, but a.m. And earlier today, basically, I finished 44th, which is yay, right? But it was a thing with a lot of issues, and like I said, some people are still in favor of ranking it because, hey, the conditions are the same as everybody, right? Then why shouldn't it count? As someone who finished high enough to actually get an increase in rating, I actually disagree. I think for ratings, right, like they're supposed to be predictive in a way. Like if you think about it as a machine learning model, and if it's predictive, then chunk data in, chunk data out. But I get that people, say like, hey, I invested time in this, I should be able to do it. But like, I think I always advocate, personal metrics and stuff like this because it's just a way to get feedback, right? Like it's in a way that you don't lie to yourself, right? Meaning that, hey, at the end of the day, if you do 10 contests, 20 contests, whatever it is, and your rating is some number, you can pretend that you're better than you are, and you don't have to pretend that you're worse than you are. So you're exactly what that number is, kind of. I mean, there is some variations, right? These numbers jump up and down, but at least you're in a range, right? Like like if you're unable to solve Q4s consistently, you know that you don't need, you don't really like whatever you did in the last contest, you know that if you are able to solve Q4s consistently, you also know that, right? Or whatever it is. So these are things that, under pressure is when, in a prolonged average, that's how it is, right? It's not supposed to be a reward, I don't think. I think that's the thing that sometimes, and don't get me wrong, this happens to me a lot as well, where sometimes I do, focus on the wrong things, right? And what I mean by that is just that, these metrics are a reasonable gauge for you to, see within yourself. But like all metrics, right? Everything can be gamed, right? There's like, what is that thing where, I mean, I think there's a saying, something, I forget the exact saying off my head, but, everything that can be measured, can be gamed, right? So just be true for yourself, right? I would say that if you find yourself, quote unquote, I did the best in a contest where there are a lot of issues, and for this contest there were a lot of issues, Basically, the server was slow, the server was down. Some people can run, some people can't submit. I mean, if you're honest with yourself, right? Like if you're like, hey, but this is my best contest. I did the best in ranks or whatever, or whatever metrics you want to do, ranks, or I finished all 4 farms or whatever, right? But like, if you finish your best ranks because, say, some percentage of people were not able to submit, and then they have to submit later, and those people are negatively affected, did you really do your best rank, right? Like, do you feel like, like I don't know about other people, but I want my accomplishments to be free of taint as much as it can, right? Like if I finish first because the server's down for everyone else except for like me and 2 people or something like this, right? Like, yeah, I mean, will I take it? Yes, I'll be very happy. I'm like, oh, I finished first. But I'm not going to like lie to myself and be like, oh yeah, I beat the usual amount of 20,000 people and finished first, right? That's just a little silly. And I don't know. And I'm saying this as someone who actually gained rating on this this contest. So I don't know. But yeah, I think. But the key point there is not about the contest rated or not unrated. It doesn't really matter if you got there because you got an artificial boost. It goes higher than you expected because some other people got pushed down lower than they expected because of server issues. In 3 or 5 contests, it'll go back to where it's supposed to be, and if it's lower, also in 3 to 5 contests, it'll go back to where it's supposed to be, right? So remember what you're here for. Remember what you're training for. Remember what you're trying to learn. You're trying to be better at problem solving. You're not trying to increase a number on a website. Who cares about a number on a website? I mean, okay, I get a little bit happy about numbers on a website too, but I don't let it, like, it's not who I am, right? I am not a number on a website. I have stuff outside the numbers on a website, but I'm just saying, you have to figure out what you want, right? Is it to get a job? Well, to get a job, no one cares about your rating. You're on an interview, they just care about whether you can demonstrate your progress. No, like, you can't hope that other people, like if your interview is interviewing 10 people, you're not going to hope like 9 other people have the service crash or something. Actually, I guess you could hope for that, and maybe that's just lucky, and some people are lucky, so hey. But still, all of the things that you can control, focus on the things that you can control, which is to learn more and get a little bit better. Is it for competitive programming? Look, if you're doing competitive programming, then you're not looking for a short-term goal, right? You're not looking. I mean, yes, doing well in the short term every time will get you that rating, but your rating is not who you are. It's only a fuzzy approximation, right? If you actually get better, you can be that rating all the time, whatever it is that you aim for, right? Which is it's higher than a little bit average, all right? Just be a little bit better. That's what I say, And you could be better by learning and being, deliberate about how you learn and all these things. I would say from my personal thing is that I do get, like I said, I do get a little bit excited and happy when I get a new rating, a new peak rating or whatever. Sure, not gonna lie. But I will also tell you that once you get there, it's the same thing as every other thing. Every other goal you have, right? Either the two ways you can go. One is that's your peak and you never reach it again. And does that make you happy enough? I don't know. I don't think so, because you're like, well, that was probably just luck, right? Like if my average rating is 2,800 and my peak was 3,000, and okay, fine. Like that 3,000 was, I had a lucky contest. My skill did not really improve. I just had a good streak, right? Or conversely, if my average rating now is 3,000, then I'm like, okay, well, yeah, I'm happy that I reached that average 3,000 rating. But after that, what's next? you know, and then you have to figure that out for yourself. You know, it's a treadmill of goals. Anyway, I actually did not intend to go for this long of a rant, but I just want to kind of point this out, you know, as a contrast thing, because what I noticed in some comments, both on my Discord and also just like the forums and stuff, is that people have all this, like, people are really invested on getting this ranked or unranked, and for me, my mindset is just, I just want to see interesting problems, and I just want to know how I react to those problems, you know, and then over time, the ratings will fix itself. I don't really worry about it. I don't really think about it. I don't, you know, I don't meet someone new and impress them with, hey, do you know my Leetcode rating is 3,000? I mean, come on. I'm listening to myself. You're listening to me. You know. But okay. But yeah, as long as you're making progress, you'll be fine. Yeah. The ratings, eventually everything will be where it needs to, or where you think it is, or where you are, right? So, you know. So just a point in time doesn't matter as long as you're making progress. Okay. I put enough emphasis on it. Let's look at today's problem. 2444, count subarrays with fixed bounds. This is a hard problem. Is this the same one as same idea rather with the sliding windows / contributions? I guess we'll see. You're given an integer array nums and two integers min k and max k. A fixed bound subarray of nums is a subarray that satisfies the following min. So this is actually in the subarray, because I feel like I misread that either yesterday or the day before about like the max element in the subarray versus the entire array. Very easily confused, I think. But okay, return the number. Oh wait, no. Yeah. I mean, you still have to get the minimum array, but it's not a variable. You're given that as an input. Okay. Return the number of fixed bound subarrays. A subarray is a contiguous part of an array. I want to also start this problem by saying that I have a lot of new viewers lately and a lot of kind of people who are new to Leetcode. So I want to say that this is not a good problem to start on. If you struggle the last couple of days, well, if you have been working on what we've been working on together on the last couple of days with respect to sliding windows and contribution, then this is probably like, it's definitely harder, but it still should be something that maybe is solvable. We'll go over the parts, of course. But I would say that if you are starting from nothing, this is a terrible problem to start. So definitely don't feel that bad for not being able to solve this. Just work on easier problems. It's fine. But I give you permission. Okay, let's see. 1, 3, 5, and then okay, it's because this subarray, the min is 1 and the max is 5. Okay. And of course, we always want to double check the bounds just in case it's something that we can, you know, beat up and exploit. N is 10 to the 5th, so n squared is gonna be too slow. We have to do better. I mean, given the theme of recently, we probably knew that, but I just wanted to be explicit. You have to do better, and we have to figure out the contribution, right? Okay. So the first thing to these things, and I think I did not put enough emphasis on it, but on previous times, it's just thinking about what to track, right? And what I mean by that is that, and this actually came up during the Q3, right, of the bi-weekly contest that I was talking about, which is to say that, you know, you have to figure out what to track so that when you add and remove, you can, you know, do things easily. I mean, I don't know that this is the way to solve this, but let's start by, you know, doing the same thing that we've been doing a little bit and just playing with the idea. What I like to call it is just finding out the texture of the problem. Why I say texture is because you're feeling it out, right? So that we can, you know, when we find things that are wrong with our assumptions, then we are able to get some observational information about it, right? Or at the very least, we found one thing that doesn't work, as is that Edison would say for light bulbs, right? I think the first thing that I may play around with, given this example, and this is where I always point out, is that I usually have a notepad and pencil that I play around with, but obviously I want people to see it on stream. And I don't mind this kind of ASCII art type thing, so that's what I'm going to do for now. But yeah. But I want to say, okay, one way that I can think about is, what if we don't have max k and we just have min k, right? So we want number of subarrays that where the min value is min k, right? This is kind of an awkward one because 1 is in the beginning, so I'm just going to add some random numbers to the beginning so that I can get a more feeling about this texture, right? So okay, so here, as we say, we have pointers. So let's say we have here, that's 0 because we don't have anything. 0, 0, 0, 0, 0, right? And then now we have 1. What does this 1 represent to us? That means that we want to, on the same idea. I don't know that this is correct yet, right? I want to explore this problem, and I want you to, explore with me, which is why we're doing this together, right? Is that, okay, so this element is the last element of a subarray. How many subarrays does it contribute to the answer? Where min element is min k, right? So then here we say, okay, well, every subarray. I think there's a little bit of trickiness here that I think I was feeling a little bit, but I couldn't figure out how to say, is that 1 is also the min element of the entire array. So let me play, because during this process, it is important, at least for me in my thought process, to come up with a case that's more general. But it turns out that this is a more specific case, right? Because 1 is also the lower bound of the entire array, so it's just a little bit awkward to play around. So let's say one min k is 2, right? Then here 3 is nothing, 5 is nothing, 2 as the last element. What happens, right? Well, what happens is that everything to the left is a degree of freedom, meaning that we can choose it, right? So that it ends at 2, we have 2, we have 3, right? So then now, so then at index, let me write it here. At index 2, we have 3 degrees of freedom, right? 3 choices. We can choose 2, we can choose 5, 2, and we can choose 3, 5, 2, right? Okay. And then now what happens at 7? At 7, we actually, because 2 is still the min, we also have 2 degrees of freedom, right? Because we need to include the 2. So then now it has 7, 2, 7, 2, 5, 7, 2, 5, 3, right? So at index 3, we could copy and paste almost in a good way. We just add 7, never lazy, sorry, right? So then now, you add that to the answer. Dot, 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 and then 5 the same thing. But then the 1, what is the 1? Well, 1, we now know that now we cut it off, right? So it actually is a pretty easy thing to handle in that we just cut it off, right? Because now anything with 1 inside, the min k cannot be 2, right? So now we have 0 right on top. We have 0, we have 0, we have 3, we have 3, we have 3, and then now it goes back to 0 because anything that includes the 1, the min k cannot be 2. So then now we go to 3 again, that's 0 because you can defect because anything to the left will go through 1, right? So this is 0, 0, and then 2, this is, we kind of just copy and paste the same thing. So it's 3, 3, 3, right? So this is assuming that min k is equal to 2. So we already made one observation, right? Which is, maybe you made it much faster than I did, which is fine, which is that, and you could kind of generalize this to max k without that much thinking. I hope that makes sense because same ideas that you cut off. So for any number, so here's an observation, right? For any number less than min k or greater than, I'll write it out, max k, we can separate the arrays, right? You know what I mean. Maybe that's not as mathematically precise, but actually I just came back from like running 7 miles, so I'm like a little bit tired. I did take a nap, so I feel okay, but some of this uses that energy. Okay, right? So then now, how do we incorporate the max part? Right? Is it easy? I don't know. Well, I mean, the first thing we do is that the max we cut out to 7, for example, but we can, you know, just play around with it for a second and think we can remove this for now. I mean, let's just you know, we already established that we can filter things out, so I'm just gonna remove these manually so that you know, so that we have a longer array. But we also already know, not filter them out, but just like partition them, right? So we already know, excuse me, we already know that we can partition them. So yeah, okay, right? So then now we're trying to figure this out for one subarray of the thing. Okay, I mean, that here we can just maybe do a little bit of a walk and do things manually, right? I think that's an idea. So 3, no, neither of these are, right? The next is a 5. That's interesting. We know that anything with a 5 is going to be max array. And I think now we can also say that because we already did the partition, knowing that we see this 5, that is good. So then maybe we can say, I don't know, don't hold me to this. This is just a running idea. This is me exploring the problem, right? So max satisfied is equal to true, right? At this point, but it's still 0. But I mean, yes, but I mean it's obviously 0 because the min is not 2. But so actually, let me write it on top. So 0, 0, right? But we also want to note this location, right? So maybe we say last max is equal to last max index maybe is equal to index 1, right? And of course maybe equivalently we have last min index is equal to none, right? And then now at 2, well, now we update this to 2, and then now what's the degree of freedom of this 5 and 2, right? Well, the degree of freedom is that we need both 5 and 2. So the degree of choice we have is just the stuff left of the 5, right? So that means that we can, so now at index 2, we have 2 degrees of freedom, right? And I say that just because now you could use 5, 2, which contains both of them, and then 3, 5, 2, right? So now we have 2, 2 is the answer in this one. 4, what is 4? Well, same idea, right? So the last is 2, the last other thing is 5, and then you have 2 degrees of freedom. So it's the same thing as this, except for you have a 4 at the end, right? And then now, does it get interesting? Oh, this is 2. Now it gets maybe a little bit more interesting. I'm going to just add a few more numbers in between because it does repeat, but okay. But yeah, now it gets a little bit more interesting because it's 5. Do we just update this? And these are the things that I'm thinking about during the contest or whatever it is that I think, okay, now that I'm here, what do I do? Like literally, right? So you're really seeing how I think about it during a contest. I mean, during a contest, I'm doing this faster and I'm doing my head and all these things instead of articulating it. But, you know, that is actually the idea, right? So then now 5, then what happens? Well, we know that this is enough to satisfy what we need to satisfy. So that means that there's actually 3 degrees of freedom, right? Because you could do 5, 4, 2 or 2, 4, 5, sorry. 5, 2, 4, 5, and then 3, 5, 4, right? So that's 3. So I'll write it out so that's more clear. At index, what is it, 4, we have 3 degrees of freedom, right? Because that's just the 3 choices that we have. I say degree of freedom, maybe I should just say choices, right? You have 2, 4, 5, right? You have 5, 2, 4, 5, and then you have 3, 5, 2, 4, 5, right? And I think that's really enough. At the 4, nothing changed, so it's going to be 3, right? It's the same thing here as here, except for now you add a 4 at the end. Same thing here, right? And then now the 2, again, the 2 and the 5 means that everything to the left of it is 3, right? So then that means that, you know, right here you have 5 degrees of freedom, so this is 5. I do want to get repeating things in a row just to kind of also show this, right? I guess it was what we're doing here. And then this 2, right? This 2 that, here we also change, I guess we didn't change the index for this one either. But the last min index is 4. Yeah, 4. And now the last min index is, I don't know what this is. Is this like 8 or 7? Right, 7, right? So then now we look at the last max index. This is 4, so we have 5 choices, right? Because it could be, you know, 1, 2, 3, 4, 5. I'm not gonna write it out, so it's 5, right? And then the next one, same thing, right? You have a 2, but you have to include this 5, so then you have 5 degree of freedom, right? And yeah, and now you have a 3. It doesn't change anything, so it's a 5. And then now you have a 5. 5, 2 is the next thing, and this has, I don't know, this is like 9. So yeah, you have 9, right? And that's pretty much it. And then you sum this up, and I'm gonna take a calculator real quick. I don't need a calculator. What is this? 15. This is 18, right? So that's 33 plus 4 is 37, right? And the reason why I want to do that is that you can do this during a contest, but I am a little bit lazy. But that means that you can plug it in here and then just check to see whether this is right. Right? You can't do this during a contest because I didn't return some random things. It's not radical. But yeah, you can't do this during a contest because they won't tell you the correct result. But here you can see that it matches us perfectly. And now this is basically the idea, right? Now we have this you know, this thing that we worked out manually on how to count this thing with this idea of contribution. Then now we just have to program it. And I know that I make it look maybe easier. Maybe I don't. I don't know. Let me know in the comments whether I make it easier or not. But yeah. Okay, the first thing I want to do is I want to partition it by I want to partition it by, you know, the 3, 5, 7 thing, the min k and max k. I think there's a group by, so you can just actually use. I don't know that I recommend this, by the way, but I actually. I don't know that I recommend writing it this way, to be honest. Maybe that's confusing, but basically it puts everything in groups, right? So you could even do GVs in right? Am I missing something? Why does it not auto indent? Let me just run it real quick, just in case I have a typo. List object doesn't have group by. What was it called? It's iter2s.group by, right? Alright. And then basically the idea is that if you print G and then convert that to a list, maybe I did the other way, I always forget. You can see that it's basically true, false, true, false. Oh, yeah, but basically the idea here is that it'll group them in true, false groups. True being things that meet this criteria, false being things that don't, and then it puts them in groups. So basically now, if, I don't know why this doesn't like auto indent correctly, but okay, if G, then we want to say, let's say total is equal to 0, then total, let's just say calculate because I'm lazy, VS, right, or list, convert to a list. VS is for, I call it values, so like VS, I don't know, right? And then now we can return total. Do I have to mod anything? No, assumes okay, okay, fine, right? And then now we can focus on on this sub problem where we already filtered out all the things bigger and smaller, right? So yeah, so okay, let's just say we don't even need this n, but I mean, it doesn't matter because technically it shadows, but I don't like shadowing, so I'll just do that. Sometimes I don't care, but I just want to get rid of it for now. So then now we're trying to solve this problem here, where we already have filtered the things out, right? So then now, yeah, so then for index x in enumerate nums, right? So then here, it seems like it's pretty straightforward at this point, right? Maybe, I don't know. We even kind of mostly pseudocode it, right? So yeah, if x is equal to last min index, I don't know that I actually handled this correctly, but we'll see. It should be okay, but maybe we're off by. Sometimes those things are a little bit tricky. Oh, not that. It's what's it called? Min k. Then last min index is equal to index. If x is equal to max k, last max index is equal to index. And then if this is not none and last max index is not none, that means that we have both values, right? We have, say we have total 0, 0, and then total we add basically the min value, because min is the one that is earlier in the thing, and you need the one that's earlier in the thing to, because that's your constraint, right? So yeah, and keeping in mind that it's this plus 1, because if you're limited by this 2, then you have 3 degrees of freedom. So something like this, right? And then now I think that's it. I mean, maybe there may be edge cases, but I think that's ideally, right? Yeah. Is that it? Let's give it a submit. Apparently this was whatever a while ago. But yeah, and apparently I got the March batch. 1461 day streak, and there you go. And wow, we solved this exactly a year ago. How did I do it last time? Did I do it okay last time? I guess I did it mostly the same as last time, except for I kind of used the manual partitioning. During the contest, I think this is during the contest, I did it this way, but I did it with a deck instead of indexing, which is kind of actually I don't know how I did this, but maybe I did it in a weird way during the contest. But yeah, but this is pretty much it. What's the complexity here, right? The group by is a linear scan, so this is linear time, and then this thing is going to be just linear, right? Because we look at each element once. Pretty straightforward looking at each element once. And there you have it. This is how I solve a problem that I honestly don't remember. I mean, it is we do get a little bit of a hint, right? Because this is the same kind of problem we've been looking the last 4 or 5 days, so that is kind of a hint. But other than that, I don't remember how I solved it. I mean, I think the way this is set up, I think sliding windows is pretty obvious to me anyway. But just knowing that sliding windows is not enough, right? As we saw earlier today on the bi-weekly and maybe this problem, you have to kind of figure this out a little bit. So yeah. Anyway, that's all I have with this one. Let me know what you think, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.